Hello everyone, welcome to another session of Value of an Hour. So today I'll be continuing the same exercise that I was doing for the last two sessions, which was sort of take a simple LeetCode problem and explore solution in different languages. I'm not like an expert in different languages, but the intention is to learn new languages here and also to share my learning process with everyone. So let's get started and I'll do a quick recap both for myself and for everyone else watching. So we'll spin up my environment here. So I'm using Ubuntu for Windows. It's open in a different monitor, which I need to, yeah. Now I think it should be visible here. Yeah. Okay. Yeah. Cool. So what I'll do is I'll go to my tools directory under LeetCode, and so far what we have been doing is we took a very simple problem in LeetCode. The problem was like two sum, probably like one of the easiest problems there, and we tried to solve it in C, and we wanted to have like a clean solution in C. And one thing that I understood, like there is no library support for Hashmap in C, so I sort of ventured into doing that. What it would it take to build like a Hashmap in C? It's probably a very good like college intro level course that you can think of. Is if you sort of try to do the same things, you would understand like the internals of an hash map. Whatever you use in your Java code or in a C++ code or any higher language code for that matter, you already have like a built-in support for hash map. So a lot of the time you don't actually get to see the internal workings of an hash map and get to implement one by yourself. This is my own session, so I'm free to do what I want to do, and that's what I'm doing here. Let's get back to our code. So from there, we'll have more things to talk about. I think let me open my VS Code here. VS Code is opened on a different window. Okay. So what we had done here is we created like a node in our hash map, and our hash map structure is an array of linked list. So typically, if you see any hash map theory, you have like a hashing function. Whenever you have a key, you want to hash into a particular bucket, and then into that bucket, either you put that value there itself, or if there is already some value residing there, you would try to append that in a linked list. The data structure can be different there, and probably you will see differences in performances as that implementation grows. But for our purpose, we want to keep it as simple as possible, and that's why we stick with the linked list here. So it's basically an array of linked lists, and that's what I'm doing here, putting some values, getting some values out. Yeah, and I think in the last session we also tested that it's working. What I want to do in this session is also visualize how this is being played out for a very varied set of inputs, because the inputs that I'm giving, I might not be actually testing how good the hash function is, or what are the different things that can actually create a very slow solution here itself. So let's actually do that. Let's actually understand like the internals of that hash map, how it's being initialized and all. So to understand any program, what we need to do is have a way of visualization. Like we want to create a way of visualization. And whenever we think of visualization, we might not always think of creating like flashy UI. The very best visualization you can do probably is on command line. So if you're able to print something, that's I think the best way to visualize. So that's I think what I'll try to do it here. What I'll try to do is basically create like what should I say? Basically a visual representation of the hash map. So what I'll do is I'll call it print map, and let me see what's my hash map structure. So my hash map is basically this map array, and I also have this hash capacity as the max value. So very well, I can do like an index, start from index 0 while index is less than hash capacity. Oops, not that. Hash capacity, and then I'll put some code here. What we want to do here is we want to check the current node. So let's take the current node, or whoever is residing in that bucket. It's actually index, not I. And we also might forget to increment that index at the end. So we want to take the current bucket, and so that would become like this. So let me try to quickly code it up, and then probably I'll explain what I'm doing there. Otherwise, we won't like do either thing properly. So then what we want to do here is let's also print this. Okay, so now it's looking actually better. So here probably you can understand what's happening. What we are doing here is we are just printing the hash map, and it basically shows the visual representation that I was trying to do with my hand. So you have like a 10 element array, And then the first element that I'm sending, 15, that's basically hashing to this bucket 8. Let's actually see what we have if we send more elements to this guy. So let's say we'll create 4 more elements. So we'll have 10, 12, 13, and all values are 20. And then we want to print map there. So now you can see that 10 is being hashed to 3, 13 is being hashed to 4, 12 is being hashed to 7, and 15 is being hashed to 8. What we possibly want to do here is we also want to create maybe a random set of inputs so we can better test this function. So let's just do that. But for that, we need to know what's the way to create random function in C. So random, and I don't know C at all, so I think that's I think. Let me reorganize the screen so I can better see the screen here. Okay, much better. Now I think I can see what is visible on the screen and on the stream. Perfect. Yeah, how to generate a random integer in C. Pretty simple. So we want a time.h function. So probably we will want a time.h. Oops. Time.h function here, and then what we want to do here, create something like this in our testing function, which is our main function. So let's remove all this for now. So this is like seeding. So we'll seed the random function here, and then we want to create a random integer. And then we want to hash that integer to one of the buckets and see what's happening. So what we want to will basically do here is we'll create a loop. So let's have I of what, and also thing that we want to test here is hash capacity. Let's just put just the hash capacity number of elements into the hash map and see what happens. So we'll copy this guy over here. So every time we'll create a hash function, and we'll basically need a key value pair. So we'll have one key and one random value as well. Doesn't matter. Also, we want to possibly trim those values just to so that we can fit in our visual representation. So we want them just to be less than 1000. So I'm creating a modulo for that. Don't need this command. And then what we are gonna do is let's put this guy key comma b printf. Okay, so just for our own understanding, because we won't be able to see what's k and what's v there, and so we're gonna do a printf of that. We're gonna put those values in, and then we'll do print map at every iteration so where we can see. Then we can also do a get character. Let's see how it works out. So the first element we got is like 401 and 601. We got at the first element. The next element we got is 405. We got it here in this bucket 8. Then we got another one in bucket 5, another one in bucket 3, another one bucket 6. Now we got a collision. Yay! So we got two elements in bucket 3 now. It's fine. We got another collision, and so this is sort of actually interesting. Like, why are we, if we have like the same key, why is the same key mapped to different buckets? So this could be some bug in our code, right? So if k is 0, then ideally let's also print the hash here. So we would know hash of %d is %d, and we put this. So this will be k, and then this will be hash code of k. So hash of 498 is 9, that is fine. Hash of 423 is 4. Hash of 810 is 3. Hash of 88 is 9. And what happens if we put the same number twice? So this is actually interesting. So we want to ideally create like some copies. So we want to keep the same key, but we want to change the values. What should ideally happen here is, this is actually an interesting thing, right? So if you have the same key, ideally you should replace that same object there. So this is actually a bug that we have in our implementation, that if you're going to put a key, while we are doing that, um, we should just replace that. We should make the changes inside the hash map itself. So if I encounter, let's say 810 again with the different value, ideally we should replace them, because otherwise the hash map doesn't make sense, right? You won't, I mean, then you would create like a very sophisticated hash map which can create like a list of ads, which also I think it's a valid possibility. Like potentially we can have that, but I don't know like any reasonable hash map does that now. So let's make modifications so we can also handle that scenario. Because right now, if you see, what would happen here is I do this one time, and then I continue to do this. So which means like I get only one key and 10 different values. What would happen in that case? So 275. Now 275 is coming. It's coming same, but I think we are uh, doing some wrong modifications there. Like we are not properly updating the value. We are not properly updating the value, because I think this is a total hodgepodge here. So ideally it should not be map hash key. It should be current next key and value. So that's I think a different bug. Let's find out 730. Okay, so now it's happening like this. So if we have like multiple elements with same keys all bucketed into the same bucket, I think that's the what behavior that I've coded in, but it should not be the case. So instead, what it should do, it should do an in-place replacement. So if I do, what's this, right? So, so think we have to make a compromise here. I think this should work. The only thing time it won't work if you have, let's say, one element and your next is not null. Uh, so which means like you have two elements and if your next is null, then it won't go inside the while loop. So it will come outside. So if you have just let's see what happens here. So yeah, this is I think the problem that happens. Like yeah. So let's see the problem that's happening. So we can actually see. So the first time we get 25. So 25 gets put into the bucket 8. The next one, this time, like when you have only one, at that time you won't be able to change it. Now onwards, it'll just replace the first element. So the next time we get 51, now the first element gets changed to 51. And see every time you notice every time this thing changes. So we'll keep on including more and more elements and this thing keeps on changing. So the problem here is like if you have just only single element and then you encounter this issue, then probably it won't be able to fix that. So what we want to do here is maybe just put another check here. Current value is value, else we can do current next. Yeah, something like that. And now if we run it, now it just does in place replacement. So basically everything is mapping to the same element and we just keep the last value that you sent. So the bug is fixed. We could possibly see we're doing multiple comparisons here. I think that's like a minor improvement anyway. So anyway, I think that's a great thing. So we have now created a hash map and now let's do the load testing that we wanted to understand. It's not actually load testing, but maybe something closer to that. First element 145, 324, 652, collision 865, another collision. So this is I think what we get here. So the capacity is 10, but the number mapping that you want to map it to, it's very large. It's 1000. So what we can do is basically change the capacity here and just make it within the capacity. So the the map of all the numbers that you're trying to put into your bucket, it's same as your bucket size. Let's see how things change, if things change at all here. And we get almost a perfect hash because it's exactly the same right now. What happens if even if we do like the twice of that? So let's just include maybe twice of these cases, and I just want to see the final state, so I don't need this. So probably I'll do that. This is also I think a little bit better. What happens if we have this number of cases? That's very interesting. So you have, is it always the same thing? That is very interesting property of this hash function. but I think it is happening because of this. That's better. So basically what was happening here is this modulo was getting precedence over 10. Now I think it's a good thing to learn. So let's look up operator precedence in C. So I think this is a good website, cppreference.com. Let's look up percent modulo, multiplication, division, remainder. These are at the same level of precedence. So the highest precedence will be these suffix, postfix, functional, array subscripting, structure union access, then structure union member access through pointer. After that, you have the prefix increment. Then you have unary plus, minus, logical not, cast, indirection, address, size of. So that's your precedence 2, but that's calculated from right to left. Multiplication, division, remainder, that's at the same level. So here, when I mention modulo and multiplication, what essentially was happening is first the modulo was happening and then the multiplication was happening. So what we are, I think if the output is still persisted, I'm not sure if it still does. But we can reproduce that here quickly. Let's remove these and put the bracket here. So now we are going to execute in the same order, right? So what is happening here is, so we are getting 90, 40, 30, 10, 0, 60, blah, 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 blah. So why are they all going to the same bucket? That's actually an interesting thing, right? Every hash function is mapping to 3. So there is something unique about our hash function. So we'll get to the bottom of that. So what is the hash function? A hash function is if we pass a number and then we multiply with a prime number and then we add a prime number, then we do modulo with hash capacity. So essentially, and the number that we are passing here is random modulo hash capacity multiplied by 10. And coincidentally, 10 was also hash capacity. It's interesting, right? Why would that happen, this thing? I am now curious. I think that I mean, there should be some explanation, which I'm not getting. I'm too dumb to get that. But I'm curious is like, there should be some mathematical thing happening here which always produces 3. Okay. Got it. So what's happening here is, let's look at the function here. So I'll just copy this thing here. So let's look at the function. And what I'm passing here is num equals some random value modulo hash capacity multiplied by 10, which is also hash capacity. So let's take this guy as some constant. It can be k1, k2, different for different cases. Then I have 10, which is essentially the hash capacity, right? So essentially every number you are sending, it's this constant is changing, then you have a multiplier of hash capacity. Now let's plug this number in case of num here. Modulo, what we can do here is, so let's take about this, right? Let's think about that. So in case of modulo, what we can do here is if we just take independent modulo of this one and this one, that's essentially, I believe modulo operations, if you have like a plus b modulo c, then that's equals a modulo c plus b modulo c, right? Shouldn't be the case. If I have 45 modulo 10, which is 5, and if I have 42 modulo 10, or let's say 22 modulo 10 and 23 modulo 10, that's same, right? So that's what exactly happening here. So 97K1 hash capacity, so this modulo becomes 0 always. Then you end up with a constant capacity and modulo. So if we just change this constant capacity here, let's say instead of 43, we just do it 47, then all of these guys will now bucket to 7 now. I don't know why it's not printing. Oh yeah, I think we just removed print map here. But I think we are able to see that everyone is bucketing to 7. The weird thing is, like, since 10 is the hash capacity, that's why it's happening. But anyway, that's beside the point. So the point was, if we have a very large number, for example, if our hash capacity is this and we have a very different number to multiply this hash capacity, and what we want to do here is we want to create a similar thing. Let's say we want to have, actually we want to create this only, right? Like hash capacity. What we want to do here, we want to just create a very large set of numbers, and each of those numbers will also be modulo of that. Got it? Yeah. So then we can have it here, hash capacity multiplied by 23. Let's copy this guy here, here. Okay. Okay. So now, instead of doing all of these things, because it's very hard to read now, right? I mean, we can't see values here. So in this particular case, we won't do that. Instead, we'll keep a count and we'll increase that count. And what we will do here is we'll just print that count out. Oh man. So it'll show how many of the values are bucketed here. Right? So now let's say we don't need to limit it by hash capacity. We can say if we have a hash capacity of 10 and then we have 500 elements mapped to that hash, then what would be the state of this guy? So each of the guys have almost like 33 kind of numbers, and I think in this particular case we have around how many? We have 10 buckets here, right? So we have 10 buckets, and then each bucket we have 33 numbers. Shouldn't we have more numbers here though? If I have just 10, my assumption is we should have 10, right? 10 elements right here at the end. 2, 3, 4, 5, 7. Okay, yeah. No, actually, there's one missing here. 2, 3, 4, 5, 6, 9. Um, if I have 5 elements, is it just I'm missing something here? No, no, here we are getting. Ah, okay, okay, okay. Yeah, so probably there are some duplicates that are coming in, so those duplicates are not being considered. Okay, now it makes sense. If we have a duplicate, I think there is no way because right now we don't allow duplicates in this case. So we're just putting this guy here. What would happen if we have uh, all the numbers mapping to the same bucket? Then essentially we'll end up with one linked list. And essentially we will end up with order n. So that's why like the lookup of a hash table, in the worst case, it can go to order n. So let's just understand hash table 101. I had to take some water break. Yeah, in computing, a hash table, also known as Hashmap, is a data structure that implements an associative array or dictionary. It's an abstract data type that maps keys to values. A hash table uses a hash function to compute an index, also called a hash code, into an array of buckets or slots from which the desired value can be found. During lookup, the key is hashed and the resulting hash indicates whether the corresponding value is stored. Awesome. So what I wanted to check here is, yeah, so the load factor. Yeah, I think I forgot this term. A load factor is a critical statistics of a hash table which defines the number of entries occupied in the hash table, and M is the number of buckets. And this is what I'm trying to do here, is define the load factor of a hash table. So if you have large number of elements that are mapped to this hash table and the number of buckets are very small, then obviously you will have a case of collision. Um, I guess like there are multiple things probably we can go in depth. We want to go if we want to go here, but let's step back. We are almost more than halfway through in this session. So what we can do is like let's see if it's usable for our use case, right? Initially we wanted to solve a problem. We have deviated a lot, which is a good thing. Deviation is what we want here, but let's not deviate too much. What we want to do here is similar kind of map implementation that we did for Java, and let's see if we can solve it using that. I think we can solve it using this approach. Let's see if this approach works. I still think probably it needs some changing because I used a function to some internals. So probably this return size need to be set to be 2. Then I have indices. Let's see if I run it. It's actually working. If I submit it, it's accepted. It's actually quite fast. And what I can do here, I can look up some fast solution, but let's try to, and what's our timeline here? It's in the runtime, it already beats like 5.14%. So I think most of these guys are just trying the same solution, right? We'll see if we can be better using map implementation. This is weird. I thought like we would be in the middle somewhere. Oh no. Oh my god. I'm so dumb. We are actually here. We're so bad. We're so bad. We just have beaten only 5%. So most of these guys are using some smart techniques. I'll look up the solutions. Don't worry. But let's see if we can beat more guys. So that's better. I thought like we only are at like top 5% of the solutions and then it's streaming. Anyway, So what we have here, we can probably create like a hash function. How many elements are there in this particular case? Um, the range it's saying the number of elements is 10,000. So I can create like a 10,000 capacity map. And what would I do? I will do something similar as in my Java solution is basically put all those elements, not put all those elements in the map. I'll just iterate the loop one time. And every time I iterate, I'll check if the element exists in the map. I'm saying it wrong. I'll check if target minus the current element exists in the map. If not, I'll just put it. Then next time, if I have its corresponding pair somewhere, that will create a match with that. Camera is pointing in a different direction. I think this is better. Yeah. Okay. So let's do that. Let's do that then. Let's do that. So I have a capacity 10,000. My node remains same. My hash code remains same. My hash capacity map remains same. Put remains same. Get remains same. Print map, I won't need it here. Possibly I'll just need this to some internal function. So which I need to modify. Data pointer to some. I'll just use that integer. What's the variable name called? Return size. Return size. So initialize return size to 2, and then we have indices, and what we would do here, we would only iterate once. Don't need to see it here. For each of these element, we'll check if so my get function will return minus let's include the limits function because I want to be more formal here. -1 is probably not a better answer. Include limits dot h, and now I'll have int min to be returned. Int min1. That is there, right? So if get target minus nums I is not equal to int min, which means it exists, then my indices 0 will be I, indices j. I can get this one. Which right, indices 1, b, j. The j is not int min. And then break. If not, we'll just put 0 with I and 1 with j. We will put not I actually, nums I with I. So my key will be nums I, my value will be I. Okay, so now let's test this function. So we have to create something like, let's comment all of this thing out. So we'll have, this is my Java habit of creating an array. Um, Something like 2, 7, 8, 9, and then we have we can just call this, right? Target, and the return size also I have to pass in. So I'll pass an address of return size. Right. Then what we want to do here is maybe just do a printf %d, comma, %d, backslash n, result 0, result 1. Okay. Got the answer. Is it correct? Should be, right? Why am I not feeling confident? Let's change it, right? So we'll see 17. Still got the answer. That just looks swapped. That's the weird thing. Ideally, okay, okay. Is it because of that? The first, yeah. Okay. So, which means we have to copy a lot of stuff here. We have to copy this to sum. We have to copy this to sum. We have to copy get, put, the hash code, and the node, and the capacity. Probably the headers. Let's see. Oops. What happened with this main function? Okay. There's a lot of code. Didn't run. Okay. So if we have 3 and 3, target is 6. Interesting. Okay. But why is it? How did it actually? There should be something wrong in the iteration then, right? Hashmap is fine. Hashmap will put 3 there. Why would it put 0, 0 here? If I have, let's say, target number. So first 3 we will insert in the hash map, right? And the next time we want to get it, we could say it's so ideally it should 2 be different numbers, it seems. Interesting. Let's see if I'm getting the same answer. Should be. There's no reason we should get different answers here. Okay, but then, I mean, output is not 0, 0, right? Um, it is very interesting. This is very interesting. Local run, I'm getting different values in local run and in LeetCode. So obviously then this, even if I submit, it will be failed, right? Because this is failing. Let me copy whatever I have here. And there is no point, it's just my paranoia doing these things. But is there some subtle bug that's crept in? Let's just draw the comparison with the Java counterpart. Just I think for my own sanity, if I am missing out anything here. That contains key is essentially get not equal to int min, which means it contains. Then we just initialize this. Okay. This would get the same thing, right? Shouldn't matter. Oops. This is just a, I mean, either I am missing out something or LeetCode is doing very weird stuff. Is it like in what possible scenario it can go 0, 0, right? I think it allows you probably to shortcut settings. Is there a way to do printfs here? Probably. Does it show std out? I doubt it shows std out. Interesting. That's a bummer. So we'll end this stream with like a or live video or session, whatever, with a question mark. Why did it not pass? I don't have an answer yet. Is it? I think my code should have some bug. My code shouldn't have bug, at least for this problem. This is like a well-known problem for quite some time. Um, only for 3. What is happening here? Give me a break. Uh, okay. It is very weird, right? So if we have any other values, any other same value, 5 and 5, and we have 10, then it's working fine, only for 3. I think the only way that I can think of probably this hash function is doing something weird. That's the only thing that I can think of. Probably let's write a better hash function. Just I think the last thing is because we can swap in swap out hash function as well, right? Hash function for we need a hash function. Then we can sort of map it back. Okay, this is super good. But I think I need like a very okay. Let's try this. I'll directly try here. And if we this is just to check my hypothesis that there is something weird with my previous hash function that's leading to this. No, it is not. So which means like yeah, I think the hash function doesn't basically matter. What happens if I can't submit, right? Because I can modify the test case and submit probably. No, it's not that. So for only for 3, it's returning 0, 0. That is super weird. That is super weird. Okay. 2-element array. I don't know. Probably in the next video, we'll do a deep dive and figure out what's happening here. Ending on a sad note. Bye-bye.